Hello and welcome. This is Barrett from the C4 Cyber Club here at Cypress College. In this video, we're going to cover the Security Plus Lab series, Performing Active Reconnaissance with Linux. So reconnaissance is essentially a term used in penetration testing or pen testing as it's often called. And this has to do with information gathering. It's kind of the first step to gaining information about a network or a particular target. So in this lab, we're largely going to be looking at Nmap. Nmap is a free and open source network scanner. It's used to discover hosts and services on a computer network. And it does that by sending packets and analyzing the responses from that. It also provides a number of features for probing computer networks, including host discovery and service and operating system detection, which we're going to take a look at in this lab. Zenmap is essentially just a GUI version of Nmap. So it uses Nmap as the source of the information and just displays it in a different manner. We'll also look at OpenVAS, or the Open Vulnerability Assessment System, which it's essentially a software framework of various services and tools that give you vulnerability scanning and vulnerability management. It includes plugins, which are written in what's called a NASL or Nessus attack scripting language. And then finally, we'll be looking at that using what's called the Greenbone security assistant, and that's essentially the web interface for OpenVAS. So a lot of things happening in this lab, but we'll go over it a step at a time. And in this lab, we'll be working, I believe, solely on the Kali machine. So I've already got that logged in here. So we're on this external network here. And I'll go ahead and launch terminal. And so first things first, we can just type in Nmap, and that's going to give us help on this, the help listing. And we see all these different options, and this is a lot of the different scan types that we're going to go over in this lab. So, you have -SN for a ping scan, -SS if you want to do a TCP SYN scan specifically. We'll be probing for version detection with -SV in a bit. So the help command, or just typing Nmap, in case you ever forget what a particular command does, that will be very useful for you. Okay, so the first scan we'll do is just a quick ping scan. And we're basically going to be scanning an entire network, the 10.1.1.0 network, the DMZ. So, consider that we don't actually know this topology, but we do know that there's a network here. So we don't know what type of systems are on it. And that's why we're just going to do this, sorry, not ping, Nmap -S, lowercase s, uppercase P, 10.1.1.*. Of course, the asterisk here is basically saying scan all of the hosts on this network. So essentially what we're doing, we're looking for replies. And based on that information, we can gather that there is a system or machine at that IP address. Okay, so we got a few responses back. Now, usually you could determine the .1 host is usually going to be the default gateway. But then we do see here a .10 host and a .12 host. So we could say, okay, there's a couple machines up on here. Now we could do some different types of scans to gather more information about those specific IPs. And of course, those IPs are correct. They relate to the DVL and the Windows 2012 server. Okay, so now we'll initiate a ping scan while also spoofing the source MAC address at the same time. And a lot of these scenarios are very situational. I think this lab, especially from a networking security standpoint, it's just giving a lot of the various network related options in Nmap. And you'll notice that we did this -v here. It's a really handy option, and it stands for verbose, because you notice it's actually displaying some output as it scans. So a -v, it will display everything. So even these host downs, the verbosity level is set. And you'll notice before we did the verbose, we didn't get any information until the scan was totally complete at that 14-second mark. Okay, so we basically see the same information here. 3 hosts up, and that's going to be the gateway. Let's see, they're all the way up here at the top. Yeah, so we see the gateway, the .10 host, and the .12. Okay, so the next scan we're going to do, Nmap-S, lowercase s, uppercase O, and then the IP. This is going to basically scan for which IP protocols are available on that host. And actually, this scan can take a few minutes. So what I'm going to do, I'm going to keep moving on. I'm just going to create a new tab here in terminal. So we'll let that run in this tab here in the background. We'll come back to that in just a bit. So moving on to another scan, we could run Nmap lowercase s, uppercase T, and this is doing a TCP scan or a TCP connect scan. So this type of scan here is essentially doing, if you're familiar with networking, this is essentially doing what's called a 3-way handshake connect on TCP. Okay, and now we see here there is a well-known port open, port 22 for SSH. SSH is what allows us to remotely connect to another machine. And now a very important scan, and like we talked about in the beginning of this video, we can do OS fingerprinting. We could try and find out what kind of operating system a host is running with the -O option. Okay, and then we have the results back. We see a lot of various ports and match to different services open. There's a SQL server, looks like it's running on port 3306. We have SSH here as well. NetBIOS is on 139 and 445, so that's related to shares. And we can see here for the OS, looks like it's somewhere around Linux 2.6.15 to maybe 2.6.26. Now let's do the same type of scan, but on a different system. So remember that one we just scanned was the DVL. Now we're going to scan the Ubuntu machine here. So we'll say -O 192.168.1.50. Okay, we have this scan back. So we have FTP, SSH, Telnet, HTTP. And then as you see also in the lab here, we find that, okay, we got no exact OS matches for this host. So there's some other ways we could do a little bit more digging. We could run another particular plugin called OS Scan Guess, and we can add that to our scan type here. So we'll still do the -O, and then we'll do /. Anytime you're entering something that is spelled out in words like a script, you want to use the double dash, and then we'll enter the Ubuntu IP address again. So now we still see no exact matches, but that's from the -O scan. But up here, we see we have a lot of guesses, and it even gives you a percentage of the likelihood of a version. So we could definitely say, okay, this is definitely a Linux machine, but is it 3.2? Is it 2.6? We're still not entirely sure, but just knowing that it is a Linux system is also very useful. Okay, and then the next scan here, we'll go back to scanning the DVL machine. And this is just a situation where we could tell it a very specific port to scan. So we could say, okay, choose port 80 and scan this IP. And this is useful after you've done your original maybe ping sweep. You're finding out what kind of protocols a system runs, and you want to get a little bit more detailed information about a specific port. And in this case, you see, okay, port 80 is closed on here. So, they may have a firewall rule that is blocking inbound traffic at the time. And we could do a similar scan, but instead of just one host, we could select entire networks. So we could say 192.168.1.0 TAC 24 and 10.1.1.0 TAC 28, which this dash at the end kind of represents the how many hosts are on the network, so it'll know how many to scan. And we just press enter. And this will probably take a little bit longer because it's scanning more systems. We'll check that out in a second. Okay, so you see we have various machines, various hosts that replied back. We see we have open ports on a lot of these. This one here, filtered. So filtered is essentially saying, I don't know if it's open or not. It could very likely be blocked by a firewall. Some more open. There's that DVL machine that we saw just a bit ago that was closed. So yeah, very useful in the case that you're needing to scan multiple systems on a network. And I'm kind of curious where we're at. Okay, so this -SO scan, the IP protocol scan, finally completed. Definitely took a while, 297 seconds. And in this case, you could just see it gives us all the details about the various IP protocols on this specific system. Okay. Now, another scan that's particularly useful for maybe a network administrator, network engineer, is packet trace script, which is going to display all packets being sent while it initiates a scan. And this is scanning on the DVL machine. So you can see that coming through. As you move on to, after taking the network security class and you take ethical hacking, I believe it's actually the first lab that covers Nmap. And you also run Wireshark, which is a protocol analyzer, packet sniffer in the background. So as you run Nmap, you actually get to see all of the packets that it creates. And this is kind of a good example of that here. So you can see when we do these Nmap scans, it creates a lot of information. A lot of packets are being sent. So that's something to consider, if an attacker is creating all this noise by doing all this active reconnaissance, somebody, if they have a good defense system set up, and they're looking at logs, they're monitoring through maybe intrusion detection systems, they're monitoring through things like Wireshark, they see all of this information come through. And then finally we see the results of the scan after all of those packets were created and sent. Okay, we could also show local host data about which interfaces are up on our machine. So this is so IF list, short for interface list. I guess you could kind of think of this as very similar to IF config. It's showing you your link local, your ETH0. This is our main network adapter. This is our IP address. This is our MAC address or physical address. We have our default gateway down here, IPv6 address. So okay, and now our last scan in the command line with Nmap is going to be the service detection, service and version detection, essentially. This is a very powerful scan, super useful in finding vulnerabilities because you want to know if the machine is running something that's outdated. So this is going to tell you the ports, which service is running on those ports, and the particular version number. All right, so that scan is complete. I can see that one took a little bit longer. We're at 175 seconds there, but a lot of great information. So we know the version of SSH. We know they're running Samba 3. something. So that's good information to go off of. And, with this scan, every host is different. So it's definitely one of the top scans that you will find you'll be using as you get into doing active reconnaissance with Nmap. Okay, so now we're going to move out of the command line and we're going to take a look at Zenmap. So we can actually just launch this right from the terminal. Just type in Zenmap. And you see that brings up the graphical user interface, or GUI for short. Now keep in mind, you do want to keep the terminal open because that is essentially running this. So you could just minimize this if you'd like. All right, and very similarly, we're going to enter in a target. And in this case, we will be targeting an entire network here, which is the internal network. So we'll essentially be scanning all three of these. And we're just going to select a ping scan here. So you notice when you select all these different profiles, the options change. And these were all the different types of scans that we were typing in the command line. So ping scan -SN. Go ahead and hit scan. And now you notice it's Nmap Output down here. What you see down here is essentially what we've been looking at in the command line. But we have a lot of different tabs and graphical visual options to look at. All right, so that scan is done. It's having us go on to another scan, but real quick, I just wanted to show how it breaks down. Actually, let me go ahead and maximize that. It breaks down all the different hosts here. It shows you a topology. So you could see that topology that you just scanned. You could point out the IP addresses. And keep in mind, we don't have anything under ports and hosts yet because that was just a ping scan. So let me go ahead and move on to the next scan. We're going to add a second network. And we're going to change the options here, and we're going to say -T5, and that's it. And we'll just go ahead and scan. And what that T5 is doing, relates to timing. And it goes from T0 to T5. So T0 would be considered the slowest scan possible, so the frequency is going to be less. T5 is the absolute fastest scan. So that's a very aggressively quick scan. As you can see, that took 20 seconds to go through 272 IP addresses, and we found that 7 hosts were up. So now, if we go through these menus, you can see we could choose the IP or the host over here, and it's going to tell us, okay, which ports are open, what service runs on that. And you notice we haven't done a version scan yet, so we don't have any of that information. Our topology has grown a little bit. We've added some more machines there, host details, and it also shows the previous scans that we've done. And we could even sort by services as well. So we could say, I just want to look at HTTP. Okay, these are the machines that are running the HTTP service. So you can see how you can navigate all this information that you're gathering much faster. Okay, so the lab is basically just having us do the same stuff that I was just showing you. We'll go to the DVL machine, take a look at ports and hosts. Yep, taking a look at services. And there is also a compare results option. So if you go up to the tools menu, compare results, we could select the different scans that we've done. So we've only done these 2 scans, and I don't believe they're very different at all, but you can see it loads up everything, and anything that's in red is what's different. So actually everything here is the same, but obviously what we scanned here was different, or the option that we selected. Great. So yeah, that's pretty much Zenmap. Don't need to go into too much more detail just because we went over Nmap so much, but it's essentially just a GUI version of Nmap, and it allows you to sort through all that information much better. Okay, so I'm going to go ahead and close that. And let's bring terminal back up. So to use OpenVAS, we essentially started as a service in it. Remember I was telling you about the Greenbone security assistant and how it's a web interface for OpenVAS. So if we're hosting a locally based web interface, we need to make sure that the proper services are running, and essentially it's like running its own web server, and we're going to connect to ourselves via localhost. So whenever you do things like that, you want to verify that your loopback interface is enabled. And if we did ifconfig right now, we see that it is currently not. All we see is this ETH0. So all we do is just type ifconfig lo up. And if I type ifconfig again, now our local loopback interface is up and running. And then we just have to make sure that OpenVAS is up and running. So we can start that OpenVAS script just by typing in the location of it. So /home scripts OpenVAS _restart. You see that's restarting OpenVAS scanner, eventually the manager, and it's going to restart that Greenbone security assistant, which is the web interface. All right, and I see we have an error on the manager. It does say in the lab, if an error appears from the script, you may ignore it and proceed as normal. So I'm just going to keep on moving along rather than take too much time troubleshooting that. Okay, so we're going to launch our web browser, or Iceweasel, up top here. And remember I said that we access this through a web interface. And to do that, since it's running locally, we just type in 127.0.0.1, and this is running on port 9392. Whoops, I may need to type in HTTPS. Yes, there we go. So make sure you type in HTTPS for HTTP secure, and followed by 127.0.0.1 :9392 for the port number. Once we get here, we just want to go ahead and accept this, add an exception, confirm security exception. Okay, so now we're greeted with a login portal. So the username is admin, password is admin. Okay, so now we're looking at the web interface for OpenVAS. Remember, it's the Greenbone Security Assistant. And we're just going to enter in the IP address of the DVL system here and just start scan. Now, the way that this web interface works, it essentially refreshes itself every 30 seconds. So this scan, I believe, will take 4 to 5 minutes, as the lab says here. So I will pause and jump back to the video once this is complete. So a good time to go make yourself a tea or a coffee and come back when the scan is done. And so you could just see here also it just refreshed. So now we're at 1% status. So it'll keep refreshing, and you could even change that to a different interval, such as 60 seconds. Okay, and as you can see, we're currently at 98%, and I actually believe that it stays this way for several minutes. So while it's finishing up, I'm going to keep going through the lab and through some of the different management features here. So we'll go into the sec info management and under CVEs. So CVEs are very important. It stands for common vulnerability and exposures. And so this is going to list all the various CVEs that are found. A really nice resource for that as well is the MITRE website. So cve.mitre.org. You can see it up here. This is pretty much the go-to for any new vulnerabilities that are found. So whenever you're doing these vulnerability scans, it's always going to link back to a CVE number, and that's what's going to give you more information about this. And you could always do more research even outside. So if I copied this and just searched for it, copy and paste it and work there. What was it? 2015, 1621. Just doing a Google search, here's a write-up on the NIST website. Here's the write-up on the MITRE website that I was talking about earlier. So as you come across these in your scans, you do some research, and usually you're going to find information about the vulnerability and potential ways to patch or fix that vulnerability. Okay, so now we'll come to configuration and targets. So this kind of relates to setting a specific target that we're going to scan. And also in the next part, we'll even set up a specific user who is basically allowed to use this vulnerability scanning system to do scans and analyze the results. But in this case, we're setting up a new target. So we're going to call this Ubuntu. And as you might guess, we're going to select the Ubuntu IP address. So for under hosts, we'll do manual and we'll set 192.168.1.50. And we could set the alive test to ICMP ping, sorry. And then we'll go ahead and create the target. And we see the target details listed here. And if we go back to the targets list, we now see that, oh no, I'm sorry, next one down, the Ubuntu as a target. And now we could also go to administration. We're going to create a new user. So say we hired somebody to be a cybersecurity analyst for our team, and they need access to OpenVAS in order to do scans. So we'll call them analyst1. Password will just be password. Role user. Host access. So we could say deny all, but let's say they've only, we've hired them to scan this Ubuntu machine only. So we'll give them, oh, I'm sorry, this goes under host address. Deny all and allow only the Ubuntu system. We'll go ahead and create that user. And if we go back to administration users, we now see that new user created here. And we see the host access. So if you log in as admin, you're allowed all. So this is kind of like setting a firewall rules, right? We're denying all, but allowing only the Ubuntu host IP address. And we could also set up schedules. So if we go to configuration and schedules, click the star again for new schedule. Let's say, okay, I want to set up an Ubuntu discovery. The first time we'll set that to 16 hours, 45. Yep, we can just set that as today. Period. We could say every 1 day. So it's going to begin at this time, which is roughly 4:45 p.m. today, and it's going to run every day. So we're getting constant daily vulnerability assessments. And if we went back to configuration schedules, we now see that new scheduled scan there. And we could schedule a task. Go to scan management, tasks. So right now we have this task running, right? Still at 98%. Like I said, it does take a long time to do that last final completion. But we're going to create a new task here. We'll call this Ubuntu Discovery. So it's basically pulling from a scan config, which tells it which type of scan. So you could do this full and fast, which I believe that's what we're doing on the other task. But we'll choose Discovery for this one. Scan targets are, we could select Ubuntu here because remember we created that as a target. And we could set the schedule that we created to Ubuntu Discovery. We create that task. Now, if we went back to, actually, if we just go back to Greenbone Security Assistant, we see that task is created. Okay, so the scan isn't quite done yet, but I'm just going to go ahead and analyze this. If you click on the one here, view list of all reports for this task, it's going to bring you to a general overview. And you see here, scan results so far, we have one medium severity vulnerability. We have 2 lows. It's also pulling just general logs. The logs are usually going to show you the various scripts that OpenVAS ran against the target IP. And now if I click on the date here, this is going to load up a more detailed listing of, you see here, this is the medium severity vulnerability. It gives you the port and the protocol. We have a couple lows here. And then we have all of those logs. So the logs can even be useful because, if you take a look at, NICTO. And this, remember we talked about the NASL. It's essentially kind of like a programming language for Nessus. It's called the Nessus Attack Scripting Language. And Nessus is another vulnerability scanner. That one costs money. But OpenVAS, even being a free and open source version, it uses their language to write these scripts. So essentially what we're looking at here is a log result of a script that ran. This program uses NICTO. So NICTO is another Linux tool for doing web application vulnerability scanning. So we see the results here. Obviously, it didn't find anything with a severity level. So, but if you want to get a little bit more details, you can look at these logs. And then, of course, we could look at this medium vulnerability, NTP monolith. So NTP is Network Time Protocol. There's definitely some vulnerabilities related to outdated versions of that. So what this is telling us is prone to a remote denial of service vulnerability. And we see the solution down here. We just need to update it. And this is why you'll hear, patch management, making sure you're updated to the latest versions is so important because, these vulnerabilities are found, they are addressed, but oftentimes people are very lazy and too late in updating everything. And that's essentially the whole reason for these vulnerability scanners, to look at everything on your host, on your network, and then judging by the severity, what to focus on immediately. If this was a really large network, we'd see a lot more information than what we're seeing right here. You're never going to not have any vulnerabilities. You're never not going to have 0 vulnerabilities, but being able to sort by severity is super important in determining what to focus on first. So that concludes this lab. Security Plus Lab series, performing active reconnaissance with Linux. So we covered a lot in this lab. We covered Nmap for network scanning, host scanning, digging for operating system versions, protocol versions, things like that. We took a look at the GUI version of Nmap, which is Zenmap. And then finally, we looked at OpenVAS vulnerability assessment system. So thanks a lot for watching. Hope you enjoyed.